We ultimately want to measure the deformation of the volcano, so how the surface of the volcano is moving up and down. The key behind this whole technique is that as the sea floor is moving up and down, the corresponding water depth is changing. So you can actually measure the depth of the water by measuring the water pressure. So we have a network of BPRs, which stands for bottom pressure recorders.
Essentially, there are very small quartz sensors that are connected to something called the Bourdon tube, which extends as pressure is applied to it. By measuring the changes of stress on this little crystal, we can record the changes in seafloor pressure as a function of time. The bottom pressure recorders are stationary, long-term instruments. They measure the pressure at the seafloor on a continuous basis for, say, 2 years, maybe longer.
Our typical BPRs have an acoustic release system.
These are subsea moorings that have a float package above the instrument and an anchor that's attached by an acoustic release holding the entire package on the seafloor. I put a transducer over the side and send a pulse, and it releases the anchor. The float package brings the entire instrument platform to the surface, and we recover it with the ship's crane.
So we had a total of 6 down for the 2015 eruption. 3 BPRs that are instruments, and then 3 additional BPRs that are hooked to the OOI cabled observatory. And what we're actually doing right now is we're putting down additional mini BPRs, which will give us a lot more ability to refine our models, to really be able to tell what's going on underneath the surface with the magma whenever there is an event. The main difference between them and the BPRs that we've traditionally put down is that these new mini BPRs that we're putting down require an ROV to collect them because they don't have the acoustic release system, they don't have any floats, so we have to actually go down and get them.
Both the BPRs and the cabled array bottom pressure recorders have an issue with drift. The mobile pressure recorder is one way of attempting to address the drift issue itself. This is sort of a survey method, using the ROV continuously for 3.5 days.
And we drive from benchmark to benchmark, making about a 20-minute measurement on each benchmark until we've measured them all. And then we turn around and we go back and we measure them all again, and then we do that all again. We should be getting the same pressure, the same depth, so we can eliminate the drift that way.
It's one way to address this problem, and it can be resolved within about 1 centimeter from year to year to year.
And that's how we get the long-term deformation signal. And by the end of the cruise, we'll have a pretty good idea of what the changes were from last time.